For question 5, we have a data set which gives us a sample of test scores from some test. So we have 9 student scores, 9 data points, and we want to make a box and whisker plot to represent it. It's just another kind of graph or visualization we can use to represent data. So a box and whisker plot, or for short a box plot, has 2 major components, the box and the whisker. We also will need to draw fences. Let's start with the box. So to create the box, we need to calculate a few things. We need to calculate Q1, Q2, Q3, our 3 quartiles. Now, just to recap, the second quartile, the definition of that, it's just the median of all our data, or the median of our entire data set. So to find the median, I need to first order my data points from smallest to largest, which I've done already. So I just need to cross off 1 from each side till I get to what's in the middle. We have an odd number of data points. We only have 9 scores, so there's only going to be 1 number in the middle. And that will be our median, 70. Q1 is simply the median of all data points less than the second quartile. So everything to the left of 70, it's a median of these 4 data points. We have 2 numbers in the middle because we have an even number in our subset 4. So our first quartile will simply be what's exactly in the middle between these 2 numbers. Halfway in between 50 and 61 is 55.5. Similarly, Q3 is the median of all data points greater than the second quartile. So I take everything to the right of 70 and I find the median of those 4 numbers, which is halfway in between the 2 in the middle. Halfway in between 85 and 90 is 87.5. So now we can go ahead and draw the first portion of our box plot. We can draw the box. So I'll draw my x-axis and I'll go up by 20s. And so to create my box spans from the first quartile to the third quartile. So the left side of my box, it'll start at 55.5, which I think is somewhere around here. So I'll draw my box, the left side of my box here. Then the right side of my box ends with the third quartile, which is 87.5, which I think is somewhere around here. So now I have my box. So I will just label Q1 is equal to 55.5, Q3 is equal to 87.5, and then I just draw a line in the middle corresponding to the second quartile, which is 70, which will be exactly here. And I'll just label that too. So the box represents our 3 quartiles. Now, I need to calculate my fences. The inner fences, there's 2 sets of fences. Inner fences are given by, we have a left and a right fence. The left fence is given by the first quartile minus 1.5 times the interquartile range. The right inner fence is given by Q3 plus 1.5 times the interquartile range. And so this will give us fences that are somewhere to the left of my box and somewhere to the right of my box. So let's figure out where exactly those fences are. First, I need to find this number, the interquartile range. The interquartile range, remember, is our third quartile minus our first quartile. 87.5 minus 55.5 is exactly 32. So my left inner fence will be 55.5 minus 1.5 times 32. If I calculate that, I should get 7.5. If I calculate my right inner fence, this should be 87.5 minus plus 1.5 times 32. If I put that into my calculator, I should get 135.5. So we can go ahead and draw those. Okay, so my left inner fence is at 7.5, which will be somewhere around here. So to draw my fence here, I simply just draw a dotted line going all the way up. And then I'll do the same on the other side at 135.5, which I think is somewhere around here. And I'll just draw my fence. And the reason that we want the fences is the fences tell us whether we have any outliers in our data set. So if any data points lie beyond this fence, or these fences, because there's a pair of them, so any data points that are less than 7.5, so to the left of this fence, or any data point greater than 135.5, so outside that other fence, is an outlier. So let's see if we have any data points outside. So this inner fence was at 7.5. Do we have any data points less than 7.5? No, because the smallest observation in our data set is 15. So no outliers on the lower end. Do we have any data points greater than 135.5? Again, no, because the highest score possible was 100. So in this case, we can see that there are no outliers in this data set. So now we can go ahead and do the last thing, which is draw the whiskers. So the whiskers simply extend to the smallest value in our data set and to the largest value in our data set, as long as those data points are within the fence. I'll talk about that in a second. So our smallest data point was 15, which is probably around here. So I'll draw a whisker down to 15, our smallest data point. And then my right whisker will extend to my largest data point, which was 100. So that's where my right whisker goes to. If I had any outliers, if I had any data points less than 7.5, I would simply draw my fence out to the fence and stop right there. Same idea if I had any data points greater than 135.5. In that case, I would just draw my whisker out to here and stop. In this case, we don't have any outliers, so we don't need to calculate the outer fences. You can go ahead and look at your lecture notes to review when you would use the outer fences and for what purpose. Okay, so now we've made our box plot. We are done with part A. So let's go ahead and move to part B. Now that we have our box plot, we can use it to describe the distribution. When we ask you to describe the distribution, we're talking about two things. And we've given you a hint. We've given you two words, shape and outliers. So when we talk about shape, we want to know, is the data set skewed? And if so, in what direction? Is it skewed left or right? So let's go ahead and answer that. We have two ways of assessing skew. One way is to look at the whiskers. Let me bring this plot down here. So we have two ways of looking, of assessing skew. One way is to look at the whiskers, and the whisker method says that the data set is skewed in the direction of the longer whisker. So remember that I have two whiskers. Oops. I have two whiskers, a left one and a right one. So I simply look at my whiskers and ask myself which one is longer. In this case, the left whisker is longer. So my data set is skewed left. Skewed left because the left whisker is longer. There's another method we can use, and this is what we call the box method. Same idea, except now we're looking at the box. And so the box method says that the data set is skewed in the direction of the larger side of the box, or the longer side of the box. So remember, the second quartile splits our box into two pieces. This is our left side of the box. This is our right side of the box. And so under this method, we ask ourselves, well, which side of the box is bigger? I can see that the right side of the box is just a hair bigger than the left. So under this method, we would say that this data set is skewed right because the right side of the box is longer. So you'll notice that sometimes these two methods will give you conflicting answers. That is totally fine. That's why all you need to do is simply justify your answer by explaining which method you use. So, for example, I would say this data set is skewed left because the left whisker is longer. That will give you full credit. Or you can say this data set is skewed right because the right side of the box is longer. This will also give you full credit. You will not get full credit if you simply just give us a direction and no justification or explanation of which of these two methods you use. So just make sure you explain your answer. Okay, the last thing that we're asking for besides skew is, are there any outliers? And if so, classify them as extreme or mild. So in this case, all our data points were within the inner fences. Our largest data point was 100, and our lowest data point was 15, which is inside our fences. So in this case, this data set has no outliers. And that's all we need to say.